Teşekkür ederim. Okay, I will start in English, sorry. I can't speak Turkish, but I will hold a presentation about our fire retardant systems and will focus on the EN 45545. Yeah, and we'll show some points how we develop these resins and how, yeah, and we'll show also a new system we have, the LEO system, where we are able to achieve very high fire retardancy with a vacuum infusion system. If we look at the landscape all over Europe, well, we see there are a lot of different standards you need to achieve. Yeah, mainly also on top the ASTM for the US or the GHOST for Russia. And with all these standards we deal and we try to find solutions in fire retardant applications. But we are hoping that the future will be something like this. Yeah, looking at the transport sector with the EN 45545, the building sector with the 13501 and the IMO for the marine and shipbuilding. These are all three very high settled standards with a need of high fire retardancy. I will show a little bit how we develop our resins. Yeah? We use a cone calorimeter in our lab, and we measure the heat release rate over the time. Yeah? With a cone calorimeter you can measure the ignition time, you can measure the heat release rate, you can look at the CO2 ratio, and yeah, these are the main factors you can look at weight loss and some things more. And so we are able to look at the fire retardant resins in a very good time. We are normally trying to sell systems and to develop systems. That means the J-code in combination with the resin. The resin alone is nice, but if you look at the applications you have, you need a J-code on top, normally a paint or a sandwich construction, and this is the goal to fit. Yeah? For the development, we divide the cone calorimeter in two parts. Yeah? We measure the J-code. You see one peak. Here's a J-code peak, and it's decreasing more and more. The fire retardancy goes down, and then a new peak coming from the resin, yeah, from the laminate. Here are some more measurements. The first thing is, if you look here, it's an unprotected resin. Yeah, you have a really high heat release rate, 500 kilowatts per square meter. Yeah, and if you look further, yeah, after nearly 90 seconds, you have the peak, the highest peak of the resin. And the resin burned away inside 5 minutes, 300 seconds, and no resin is there. Full fire scenario in this time, and that means, yeah, after 5 minutes there's only glass left. Yeah, and if you have no fire protection, with fire protection you can do it a little bit different. Yeah, you have possibilities to use fillers, mainly maybe ATH. Yeah, you can reduce the peak, yeah, the heat release coming from the resin. And if you go to intumescent systems, you are able to reduce it more. Yeah, and even you can deal with the peak of the resin, yeah, the withstand of the J-code you have. And you see the resin peak comes later and later if you use the right J-code. This combination you can deal with and try to find a real solution. If you look at the status quo, yeah, we have, yeah, you can gain the EN 45545 with a highly ATH-filled systems. Yeah, really a lot of ATH inside. You have no problem to achieve HL2 minimum ratio, and sometimes HL3 is also possible. Yeah. If you look at halogenated systems, they have a very good fire retardancy. Yeah, and also the heat release rate is not so bad. But if you look at smoke and toxicity, you will fail. Yeah. The combination of halogenated ingredients will not fit the new standards, and that's what the focus should be. If you look at an intumescent system, you have the possibility to use a J coat, which builds up a barrier. It's foaming in case of fire and isolate the surface. Then you can use a moderate filled ATH system to gain the standard. Yeah, and you see HL3, HL2 is possible. Overall, it's an HL2 with this system here with the S270, S570. How to choose the right system? There are a lot of influences you have during a choice building a part. Yeah, you can look at the application you want to have. Yeah, do I look at hand layup or spray up, RTM, vacuum infusion? Will I build up lightweight parts or structural parts? The price is one of the items. It's not we should not forget. Yeah. The laminate construction, the classification, do I need a HL2 or HL3, and the end use of the finished part is also necessary. It's a part outside, it's inside. Do I need an insulation or paint on top? There are a lot of questions you have to answer inside such a kind of project before you decide this product I will use for my thing. Yeah? That's what I mentioned before. Our goal is to have an overall system, a safe HL3. HL2 is in the most cases 85% of the applications are in HL2. Yeah? HL3 is only metro or mainly metro, or areas with a lot of tunnels. Yeah. If you look at ATH filled systems, we need a high filler ratio. That means normally only hand layup and spray up is possible. Yeah. I will explain it a little bit later. Yeah. You have fillers inside, you have high densities in the resin, so lightweight and structural parts are not possible anymore. The price of ATH filled system is really good. Yeah. You have limits in the laminate construction, and the classification, if you want to work really good with it, goes in the direction of an HL2 resin. Yeah. To sum up ATH filled systems, they're most common in the market. They are absolutely in use, but you need a high filling ratio for the HL2 classification. Yeah, and that results in a reduced workability, and the focus is in hand layup and spray up. Yeah. But the systems have a really good toxicity and smoke behavior. ATH evaporates water from the source and thinner the gases, and you have more or less white smoke. Yeah, so you have a chance to escape. Yeah. If you look at intumescent system in the front, using a J coat in front, you have the chance to use a hand layup and spray up, yes, but for some applications it's also possible to use a vacuum infusion or an RTM system. If you can do it, you can look at lightweight or structural parts. The price of the J coat is even higher, but you can, if you look at the whole construction, you reduce the price of the whole laminate. I will show it also on the next slide. Yeah? We are a little bit limited in laminate construction, but the classification, everything is possible, HL2 or HL3. Looking at the system, S270, S570, you can also choose the 8175 as a resin, which is familiar here in the Turkish market. People know this resin. And due to the reduced ATH content in the resin, you have a faster processing. It's more like a processing parameter like a DIN 5510 system, and not what I only need for European standard. You have savings in weight and better mechanical properties. Now if we compare a highly filled resin with a S570. Yeah, both systems achieve the HL2. Yeah, this is also an ATH. Oh, sorry. Yeah, thank you. This is also an ATH filled J code, but we only measure the time we need for the laminates. Yeah. If you see, we are much more faster with this system with the intumescent J code on top. Yeah, and also the fiber content is much more higher. Yeah, and that results in much more better mechanical properties. And if you have this, you can maybe reduce one layer of fibers. Yeah, you have the same mechanical properties if you reduce something, and so you can save weight and save costs. Here's only an overview of our family. We have, meanwhile, with classifications to the railway standard, some different. We have some different intumescent systems. We have the Leo system. I will tell you a little bit later, and we have also different resins, ATH filled resins, and an unfilled resin, with a liquid fire retardant additive inside. Yeah, and this system, the Leo system, I want to introduce a little bit more. And the application is focused on RTM and vacuum infusion. Yeah, you can build up really lightweight parts, but also structural parts, and that is the big difference. The price. If you ask me about the price of the components, you will never buy the system. But if you calculate it, going too deep in the laminate construction, then it will fit. And you are cheaper than a hand layup system. It could result in a cheaper than a hand layup system. Yeah? Classification also possible HL2 or HL3. The Leo system, we developed together with Zatex, and it consists of 3 parts. Multi-axial fabrics, where we have fire retardancy on top, then a fire retardant vinyl ester resin with liquid fire retardancy inside, and a protection layer, something like a J coat or a top coat on top to achieve the highest fire retardancy. Yeah, the only with the reinforcement, we have the fire retardants on top, the same mechanical properties like you know from multi-axial fabrics. It's also possible in carbon, not only in glass. Yeah, you have the same drapability and permeability issues, and it's the focus was in generally for the whole system that we are halogen free. The infusion resin, suitable for infusion, we can create a really long pod life for big parts, and we have high mechanical properties, and coming from the backbone, from the vinyl ester backbone, also chemical and scratch resistance. Yeah, and you can cure it at room temperature. Yeah, with the protection layer, we increase the fire retardancy, and we generate low smoke and low toxicity. Yeah. The reason why we choose such a kind of system is that we try to achieve really high glass content. Yeah, we are talking about a glass content of 70% weight percent, 70 weight percent. Yeah. I have here a picture of an epoxy laminate with 60 weight percent of unidirectional fibers. Yeah, here this is 20 microns. Yeah. If you want to work with ATH systems, here are some normal ATH types, some typical ATH types. If you look at the diameters at the top cut, it's much more bigger than all the holes you have in the laminate. How won't you go with ATH? There are solutions. We are also providing very good ATH filled systems. I don't want to say that it's not possible, but with this high glass content, it's really, really difficult. Therefore, you can use more like shop sand mats, but with less in strength. You have only strength in fiber direction. going back to the concalorimeter curves I showed in the beginning. Yeah, here we combine a normal vinyl ester without any fire protection. You see, the value is not as bad. Yeah, I show you an unprotected system has a value of 500 in the beginning. Yeah, and here we are only at 180. Yeah, that's the glass content. So we're living from the high glass content. So we have not so much possible burning material inside. If we look at the Leo system, we are much more lower. Yeah, and the borderline for the HL3 is 60. If we go a step further and look at smoke and toxicity, yeah, we have high smoke values with an unprotected system. Yeah? With the Leo system, it's really, really less. And we have a big decrease of smoke production, total smoke release, and also the starting of smoke production is really delayed. So you have a safe system. Looking at a laminate, yeah, we tested 20 minutes at 50 kilowatts per square meter in the concalorimeter. That means 780 degrees C on the top. Yeah, you make a foam in this area and we grid it down, yeah, and you see the laminate is almost untouched. Yeah, and we repeat this test also with 4 kilonewton on top, yeah, with a pressure, and nearly nothing happens. Yeah. These are the values we tested for the Leo system. A lot of space. Yeah, it's a good HL3, and we have a lot of space. Full paint on top, full sandwich construction, which we have to incorporate. We did a lot of testing with this system. Yeah? A lot of rare things. Even the French standard with the M1, F1, the Spanish one with the M1, F1. That means 20 minutes without ignition at a heat source of 30 kilowatts per square meter. The British standard with the category 1B, 5510, okay. ASTM with this flame spread index, it's okay. And we also passed the GOES. We are possible to make trains for metro and also for normal trains. Looking at the building, we have also high or good test results in the building area, with the BS2D0, the B1 according 4102, class 10 according British standard, and we passed the STME 84 with a class A. Also the IMO, yeah, we have the part 5. We pass it with so low heat release that we don't have to test smoke and toxicity. That's inside this standard. If we compare mechanical properties, yeah, it's not only fire retardancy, the system allows also looking at the mechanical properties. This is a S570 I mentioned before. We have it in a glass fabric, 25% volume fiber content. That means nearly 35% of weight percent of glass. And you see, if we test it, we have a fracture in the laminate. The interlaminar shear strength is not as good. With the Leo system, the fiber collapses afterwards, after the tests. We increase the stiffness much more, and it's a little bit unfair the comparison between these two, because we have much more higher glass content, but this is possible, and that gives you the possibility to reduce the layers and build up a complete new construction with much more higher quality. Yeah. This also the tensile E-modulus is much more higher. If we go to fatigue strengths, we also tested Wöhler curves. Yeah. This is a Leo system, and after 10 million cycles, we are higher than the laminate, 88-bit laminate before it starts. we can compare it with a typical epoxy which is used for manufacturing rotor blades. Yeah? I have no fear to use the Leo system as a rotor blade resin. Yeah? Because the properties, mechanical properties, are really good. Some other tests looking at marine. Yeah, we have here kerosene bars that will be ignited. Now this test is 12 meters high, and there are sprinklers, quenchers. Yeah? And if they ignite the fire, after 5 minutes, the whole wall is burning. Yeah? Then they activate the drenchers, and the fire will be controlled. This is with an unprotected laminate. You can see the values also on the table. Yeah? It starts burning, and then it increases. Yeah? Here in a full fire scenario. Yeah? And just before crossover, I know the name, not in the moment, sorry. Yeah? And then the drenchers are activated, and it's going down, and is on the line of a non-burnable material. If you look at the Leo system, yeah, also the fire is fully developed. Yeah, but after stopping the fire in the bars, the system will self-extinguish, and the drencher activation is not needed. Yeah. If you look at the values, yeah, here the other system goes up to 5,000 here, and yeah, we have only 500 kilowatts more. Some application, possible application, or some applications, the first ones, some bigger projects I am not allowed to say anything in the moment, yeah, because they are running and coming soon. But this is a small one. Yeah. So here was only the intention to reduce weight, and so we go from a hand lay up to an infusion system, with a Leo system. It's really this small part, which was something like a training, but it works. And this is much more interesting. Yeah. We replace phenolic prepreg with a Leo system. Yeah. We are much more faster in time, 3 times faster, because the prepreg has to put every layer, and I don't find the right word. So yeah, you have to close it every layer and find the shape. Yeah, and with the Leo system, yeah, we do it in one shot. Yeah, we have not the problem with formaldehyde in the system, which is inside the phenolic ones. Yeah, this is passing the British standard, and you have no repair. Yeah, afterwards. Yeah, what you have in. You have a lot of finishing time for the phenolic ones. This is one thing I am not allowed to say too much. Yeah, but looking at this front end, yeah, it was produced in the past with an epoxy prepreg. Then our customer lost this business. Yeah, it goes in a hand lay up, ATH filled to Poland. It's coming back to Germany using the Leo system in infusion. And that's showing you, if you do the right calculation, do the right laminate, then it's possible to have it with the infusion system. This is one example. It's a Metro Oslo, but it's only a case study. Metro Oslo delivered by MEDA. Here's some other parts, walls, sanitary walls, really complicated shifts, yeah, but you can do also in vacuum infusion. Yeah, to sum up, I'm sure ATH filled systems will stay as an art of the will stay at the state of art in the near future. Yeah, it's a combination. In combination with the intumescent system will help this staying much more longer in the market. Yeah. With the Leo system, you can go other ways. You can, you have new opportunities. Yeah, you can achieve high mechanical properties and outstanding fire retardancy, and that's in combination. Yeah. You are allowed to use a normal infusion process. Yeah, it passes a high fire retardant needs in railway building and marine sector. Yeah, and it's available in a wide range of fabric construction. Theoretically, we can do every multi-axial fabric, unidirectional up to quadriaxial, in carbon and in glass, as you want, and as a volume is behind. And it's difficult to run over the machine only some meters. Yeah. The first repetition parts are in railway, and we are in some series, and we are hoping to go further. Yeah, here are some other small applications. Yeah. Okay, I want to thank you very much for your attention.